Welcome to my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chittikari, Dharmapur. In this video lecture from upcoming semester terminal 2, Unit 4, Cogeneration and Basic Power System. As we discussed about previous Module 1, introduction about the cogeneration unit. From Module 2, different types of cycles are used for the cogeneration unit. From Module 3, we have to detailly studied about what are the factors affecting for the cogeneration unit, and also studied about the advantage and the disadvantage of the cogeneration unit. And finally, we have discussed about the applications of the cogeneration unit. From the factors influencing the cogeneration choice, first of all, we should discuss about the basic electrical load matching, base thermal load matching, electrical load matching, and finally thermal load matching. From that basic electrical load matching, in this configuration the cogeneration plant is sized to meet minimum electricity demand of the site. Based on the historical demand curve, the rest of the needed power is purchased from the utility grid. The thermal energy is requirement of the site could be met by the cogeneration. Second one is base thermal load matching. Here the cogeneration system is sized to supply the minimum thermal energy requirement of the site. Standby boilers or burners are operated during the period when the demand for the heat is higher. The prime mover is installed operated at full load at all times. Third one is electrical load matching. In this operating scheme, the facility is totally independent of the power utility grid. All the power requirement of the site, including the reserves needed during the scheduled and the unscheduled maintenance, are to be taken into account. While sizing the system, this is also referred as a stand-alone system. Finally, we have discussed about the thermal load matching. From the cogeneration system is designed to meet thermal energy requirement of the site at any time. The prime movers are operated following the thermal demand. During this period, when the electricity demand exceeds the generation capacity, it is difficult to can be compensated by the power purchased from the grid. Similarly, if the local legislation permits electricity produced in excess at any time may be sold to the utility. These are all the factors, very important factors to load matching of the electrical load and the thermal load. Finally, the electrical load matching and the thermal load matching from this cogeneration unit. Next slide, these are all the important technical parameters used for the cogeneration unit. From that cogeneration unit, very important for that, while selecting the cogeneration system, one should consider some important technical parameters that assist in defining the type and operating the scheme of different alternative cogeneration systems to be selected. Heat to power ratio, most important technical parameters influencing the selection of the type of cogeneration system. The heat to power ratio of the facility should not match with the characteristics of the cogeneration system should be installed. As we defined as the ratio of the thermal energy to electricity required by the energy is consuming facilities. From this unit, we have the basic same energy unit is used for the cogeneration is kilowatt. From the cogeneration system, the heat to power ratio for the back pressure turbine 4.0 to 14.3. From the power output from the back pressure turbine is 14 to 28%. We get the overall efficiencies 84 to 92. From the extraction condensing steam turbine, the heat to power ratio is 2 to 10, but in the output is we get 20 to 40. The overall efficiency of the extraction turbine is 60 to 80%. From the gas turbine unit, the heat to power ratio is 1.3 to 2.0. From the power output, we get 24 to 35. Finally, we get the efficiency 70 to 85%. From the combined cycle unit, 1.0 to 1.7 heat to power ratio, but the output is we get 34 to 40%. Finally, we get the overall efficiency 69 to 83%. From the reciprocating engine or diesel engine, we get the heat to power ratio is 1.1 to 2.5. We get the power output from that 33 33 to 53, but in the overall efficiency we get 75 to 85% from the reciprocating voltage. Next slide, we have discussed about the quality of the thermal energy needed. From the quality of the thermal energy required or temperature or pressure also determine the type of cogeneration system. From the sugar mill, we need the thermal energy is 120 degrees Celsius from the topping cycle of the cogeneration system. But in the bottoming cycle, other hand of the cement industries or glass industries or ore industries or chemical industries, that the temperature is 1450 degrees Celsius. As I told previously in the module 2, from the bottoming cycle, the cogeneration system can meet both high quality thermal energy and electricity demands of the plant. From the load patterns, the load will be the heat and the power demand patterns of the user affect the selection of the cogeneration system. For instance, the load patterns of two energy consuming facilities shown in the figure would lead to two different sizes possible type also of the cogeneration system. From this graph, we have to from the factory A, from the dotted line is a thermal energy, thick line is for electricity from the factory A. From the another factory A, we get the proportionality from thermal energy and the same peak point from the thermal energy and the electricity is used for the factory 2. And also the electricity buyback. The technical consideration of a cogeneration system must take into account whether the local regulation permit of electric utilities to buy electricity from the cogeneration or not. The size and the type of the cogeneration system could be significantly different if one were to allow the export of electricity to the grid. Finally, we discuss about the point is retrofit versus new installation. If the cogeneration system is installed as a retrofit, the system must be designed so that the existing energy conversion system such as boiler can still be used. In such circumstance, the option of the cogeneration system would depend on whether the system is retrofit or new installation. Next point is the fuel available. If you are operating the cogeneration system, the fuel is very essential. The availability of the fuel, depending on the availability of the fuel, some potential cogeneration system may have to be rejected. The availability of the cheap fuels or waste products that can be used as a fuel as site one of the major factors for the technical consideration because it determines the competitiveness of the cogeneration system. As I told about you previously, from the municipal waste or vegetable waste, from the decomposition process, from the fermentation or anaerobic digestion process, from the process we get the methane, and the methane is used to because of the waste is useless for other application, and so that's why we have to utilize the waste in the vegetable waste or municipal waste to produce the waste, to produce the methane gases, and to utilize that to produce the electricity with the help of the combined cycles of the cogeneration unit. As I told about you that from the rice mill we need a mechanical power for milling and heat for the paddy drying. If the cogeneration system were considered, the steam turbine system would be first priority because it can use for rice as a fuel, which is available of the waste product from the mill. And from that rice mill, that is we have to from the rice as this fuel to use to for the cogeneration to produce the steam. And also combinedly, I tell about you from the sugar industries also, with the help of that extraction of the molasses, after we get the bagasse from the sugar cane. So we can utilize the bagasse to produce the steam and to produce the electricity from the sugar mill. Again we have to using that energies used to run that sugar mill, and these are all the waste products also to utilize the further. And one more technology from the briquetting method, from that sawdust or other dust, what are all the waste products available from that from the carbon content, we have to utilize that briquetting technology from the furnace. Again we have to utilize. After that, system reliability. Some of the energy consuming facilities are reliable power and heat instance. So next point is we have to grid dependent systems versus independent system. From the grid and the independent system, we have to utilize the cogeneration unit, and also we should consider about the local environmental regulation. We should follow the local environmental regulation can limit the choice of the fuel to be used for the proposed cogeneration system. If the local environmental regulations are stringent, some available fuels cannot be considered because of high treatment cost of the polluted exhaust gas, and in some cases the fuel will be itself. Next tabulation we have discussed about the typical cogeneration performance parameter. We have using the small reciprocating engines, we get the nominal range from the electricity is 10 to 500 kilowatt. The electric generation heat rate is 2650 to 6300. Finally, we get the efficiency for electrical conversion is 20 to 32. From thermal recovery 50%. Overall cogeneration efficiency is 74 to 82. From that larger reciprocating engine, we get the efficiency 76 to 80%. After we have to operating the cogeneration unit from the diesel engine, we get 10 to 3000 kilowatt from the nominal range from the electrical. After the generation, we get the 2770 kilocalorie to 3775 kilowatt hour. From that electrical conversion process is going on 23 to 38%. Thermal recovery is 15%. After that overall cogeneration is we get 73 to 80. So as I told about it, from the gas turbine we get the efficiency 74 to 81. After that large gas turbine we get the efficiency 78 to 81. Generally the gas turbine is running with the help of the natural gases. The low pressure air is entered to the compressor. It will be delivered from the high pressure areas goes to the combustion chamber. With the help of the combustion chamber, we have to ignite the fuel from the natural gases. After that, we have to rotate the gas turbine to produce the electricity. After to recover the flue gases from that gas turbine unit, so we have to produce the steam with the help of the flue gases. To produce the steam, again that steam we have to rotate the steam turbine to produce the electricity, and also used for the useful applications. From the steam turbine, there is a general thermal power plant. We already I told about 65% of the losses happen on the thermal power plant, but if only we have the electrical conversion is 17 to 35%. These are all the advantages of the cogeneration system. Back pressure turbine, we get the higher fuel efficiency rating, and steam turbine and fuel firing power plant, the simple plant well suited low quality fuels are advantages. From the gas turbine plant and waste heat recovery boiler, the good fuel efficiency, simple plant, low civil constant cost, less delivery period. From the combined gases of steam and gas turbine unit from the waste heat recovery boiler, optimum fuel efficiency rating, low relative capital costs, less generation period, quick startup and stoppage, less impact on the environment, and also it is used for the high flexibility in operation. After that, we have discussed about the diesel engine and waste heat recovery boiler for the cooling of heat exchanger. It is a low unit civil constant cost due to block foundation and the least number of auxiliaries, high power efficiency in the diesel engine. Better suitabilities are standby power sources for the small unit. These are all the disadvantages used for this type of back pressure turbine, steam turbine, and gas turbine, and combined cycle of the cogeneration unit and the diesel engines. From that next slide, we have discussed about the case study. Whether you can study about the economics of the gas turbine based on the cogeneration system. There is a two method. One method is a alternative method, gas turbine based on the cogeneration unit. From the applications of the cogeneration unit, we have to using the applications for various applications. One is a petrochemical industries, fertilizer, sugar mill, textiles, paper mills, man-made fiber unit, pharmaceuticals and the drugs, and also used for the food and the dairy unit, district for heating and cooling for hotels, hospitals, shopping complex, software technology and farms. The cogeneration is very necessary for nowadays. From the power demand, from the food industries, meat and vegetable dairy products, wine and beer and the pharmaceutical units. From the people applications, we have the hotels and the hospitals, military and the correctional and the corporate and the college campus. Process of water treatment process, textile and mining and the plastics. This is the diagram is show for the cogeneration principle. As I told about it previously, from the case study and also from the cogeneration principles are used for the various engine coupled with dynamometer, gas turbine is coupled with dynamometer, fuel cells and the steam boilers to produce the useful applications. Thank you.